Yeah, sure. Excellent. Okay, so we're doing lesson 4. We're going to do some more transformations. Specifically, we're going to be completing the square to get into standard format, which is this one here. And then we'll also practice going from standard form into general form, which is easy enough. Okay, so that's just a reminder of the two formats we've looked at. Let's see, what's this big blurb? When the equation of a quadratic function is in general form, most of the characteristics can't be identified, right? Like you can't get the vertex out. You have to solve for the x-intercepts, which you have to do anyways if you're in standard form. Basically, sometimes it's useful to be able to go from general form into standard form. Do you guys agree? Mm-hmm. Okay, and the way to do that, so to go from general to standard form, you're going to CTS. What does that stand for again? It's not an Asian boy band. CTS? Complete the square. Yeah? But it's going to look a little different. So let's do this example, see what it looks like. So the thing is you don't have 0 on this side. So remember when we did it last unit, the first thing we did is we moved the constant term over to the other side. Now we don't, because then we'd have y minus 10 and it doesn't make our lives easier. So I'm just going to say we don't move the c term anymore. We only work on one side of the equation. So we only work on one side of the equation. I would say the main principle is remember that you can't change this at the end of the day. Right? So if you start adding a number, then you also have to subtract that number, right? So if I add 2, I just changed my equation. But if I add 2 and subtract 2, did I change anything? No. Okay, so that would be the main thing to remember is maintain, the balance by adding or subtracting. So I'm just going to say by add, subtract numbers to the equation. All right, so let's see what it looks like. So if we were completing the square, we're not interested in the c term, we're interested in making this a perfect square trinomial, right? So what were we doing? We were taking the b term, we were dividing it by 2, and we were squaring it, and then we would add to the equation, right? From the last unit? Yeah, that's what we did. So what we're going to do is we're going to take the negative 4, we're going to go, okay, well, we got negative 4 divided by 2, we're going to square it. I'll show the middle step, so you get negative 2 squared. So the magic number to make this a perfect square trinomial will be adding 4. Yeah? So we can rewrite. So we got y equals, and it was x squared minus 4x. And now in a different color, I'm going to add the 4. Right? And then I still have the plus 10, right? But I just added 4 to the equation. I changed it. So at the same time as me adding 4, so I'll put some brackets around there, because that's my perfect square trinomial, I need to undo adding 4. So how do I undo adding 4?
Minus 4.
Yeah, just subtract 4. And then don't forget about the plus 10 that was originally in the trinomial, right? So that just came from there. So if I changed anything, like if I, get rid of those brackets which aren't doing anything right now, do I still have the same equation?
Oh, yeah.
Yeah, I still got the x squared minus 4x plus 10. I added 4, subtracted 4. That overall is 0. Yeah? But now, look, that's a perfect square trinomial. So now you can factor that. So if you want to, circle this because it's your notes and say, oh, that's a perfect square trinomial. So now I can write, okay, well, that's x minus 2 squared. Just a reminder, the negative 2 comes from here, right? If you want a quick shortcut, it's always whatever b divided by 2 is before you square it. Okay, and then what's negative 4 plus 10? 6. There. What format is that?
The standard.
The standard is the standard form. Voila. So if you complete the square in using that method, you'll always get something in standard form. And what's the useful thing about that? Well, now I know where my vertex is. My vertex is negative 2, 6. Or sorry, plus. I was just making sure you guys are awake.
And it
Negative
can.
2 and 6.
Oh, yeah. Plus 10.
Everyone good? So we'll do more, but that's the basic gist of what we're doing today. And then, like I said, we'll also be going from standard form back to general. So let's just do another example. So, well, we just did this one. Silly me. But we can draw the picture. So we did it. You guys want to do it again?
Sure.
See if you can remember? No? So that's how I do it. Like and then I write the plus 10 out here, and then I'd be like, okay, this number divided by 2 squared is positive 4, and then I'm like, got to do the opposite out here. So that's what it might actually look like if it wasn't my notes. And then I would just jump straight to here. So it's the one we just did. But that would maybe be all the work you really need to show me. Yeah. So now we can do the vertex. So we said positive 2, 6. The axis of symmetry is always the x value of the vertex, so it's x equal 2. Let's see, is this a max or a min?
This is a max because there's.
So I guess the real question is it opening up or down?
It's opening.
It's opening up.
So it's minimum.
And how do we know it's opening up? Sorry, a is equal to 1, so it's positive. So when it opens up, then you have a minimum. Okay, so let's go graph this.
Shut up.
Wait, A is
So 2, 6. 1, 2, 3, 4, 5, 6. Wait, 2, 4, 6. Okay, and we know it opens up, so I'm just going to label that. So for the range, though, can we do the range right now?
The range is.
We can, if we know the vertex and we know if it's opening up or down, we can do the range. So remember, if it's opening up, this will be the lowest y value you'll ever have. So you want to say y
is less than or equal to 2.
6.
Oh, 6.
greater than or equal to 6. Yeah, you'll get the y value.
Great.
And then if you can remember y element of the reals, that would be good.
Y element.
And still mark you correct if you just wrote y greater than or equal to 6.
Range is.
We don't know the y-intercept, but how do we find it?
So wait, range is y.
X equals
Domain is
0.
x, right?
Yeah.
Yeah. Okay.
I don't know why we don't have domain in here, but domain's always the same, right?
Shut up.
What's the domain? X?
X is
X element of the reals,
X
right?
element. Wait, is it always?
Okay. The y-intercept will be x equals 0. Okay, so if we quickly go to our equation, and you could probably do it in your head, like 0 minus 2 is negative 2. Square it, you get 4 plus 6 is 10. So y-intercept is 10. So let's see. That's 6, 7, 8, 9, 10. Perfect. I knew it was going to be 10. So that's enough to draw that branch. And then what's the trick you can use here? Like, because these things are symmetrical, right? So I know that I was here and I went over 1, 2, and then 1, 2, 3, 4. So on the other side, I should have the same point. So if I go over 2 till I get to x equal 4 and go up to 10, I know that's another point on my graph. So this would be the point 4, 10, just to make it clear. And that would be enough. They're symmetrical, so I use that all the time, where if I know this, then I just say, okay, well, from here to here is 2, and I go up 4, so I can mirror it on the other side, go to the right 2 and up 4. You'll have a point there guaranteed, because parabolas are symmetrical, okay? What are your other options to find points on a parabola, by the way, if you have the equation? It was the very first way we sketched them on that first day. Table of values. Like, so at no point should you ever be scared of using a table of values, right? Like, so I could just be like, well, I know the y-intercept, I'm gonna plug in x equal 3 and see what I get, right? And you just go here, plug it in, get a value. Like, you should be able to sketch these no matter what, if you have the equation, because you can always do this. Yeah. The y-intercept is 10. We plugged in x equals 0. Yeah, so we got 0 and then negative 2 squared is 4 plus 6 is 10, yeah. So are there any roots for this one?
No.
No. And if you tried to plug in y equals 0, you would just get something that's not factorable. Right? Which happens all the time. So I'm going to really quickly show you when you plug in 0 and you try to solve. I mean, and if you know it's opening up and your vertex is here, like, there's no roots, right? Like, it's obvious there's no roots. Like, it'll never cross the x-axis. But say you didn't start sketching it or you didn't think about it, so you start trying to solve this. What is it, plus 6? So your first step is move the 6 over to the other side. And what are you going to do to get rid of the squares? You're going to square root it, but then you're like, oh, can I square root a negative number?
No.
No, so it just means there's no roots. Right? You can't square root a negative number, so you won't get a solution. Alright? So that's what it looks like mathematically. That will happen to you. Like guaranteed somewhere on our quiz or test that'll happen to you. So you have any questions about this one? That's basically the gist of the lesson. Like once we go from here to general, that's really everything that we're doing. So I mean obviously we'll do more, but everyone feels good about it? Yeah. I mean we did most of the hard work in the last unit, like learning how to complete the square. That was over the last unit. We can do another one. We won't sketch it, but we'll do another where we complete the square. So this one's interesting because when we complete the square, so we're going to do it for 2x squared plus 16x plus 24. Are there any rules about what the a value needs to be? Yeah, so that's the point in this example. Just recall a has to equal 1 in order for a complete the square algorithm to work. So to complete the square. Okay, so if it's not equal to 1, so factor out a if it's not equal to 1, you gotta factor it out. Okay? So whatever it is, you pull it out. So if it's a 2, I'm going to divide everything by 2, but I can't just do this, right? Because I'd have to do it on both sides of the equation, and this makes it more complicated. But you can pull it out and then throw a factor in front of it to keep it equal, right? You just need to keep it equal. So what's the opposite of pulling out a 2?
Multiplying it by 2.
Well, I guess, in this case, is everything divisible by 2? So could I just go like this and go, okay, this term divided by 2 is x squared. What's 16 divided by 2? 8. And then 24 is 12. So you pull it out in front. Okay, so that's what I meant, is like just pull it out in front. So do whatever you need to do. Like if it was a 3, I would have 16 divided by 3 right here. Right? If it doesn't work out evenly, you just write 16 divided by 3, 24 divided by 3. And you just have to deal with the fractions. Okay? But now I can complete the square in here. Okay? So you keep the 2 out in front. And I'm going to start using square brackets, because what I like to do is I like to write the 2 terms that have the x together with a little bit of room. And then I got the plus 12 like that. So that's what I like to do first. And then I'm just going to do my completing the square algorithm. So I'm going to take the b term and just do it off to the side here. I'm going to go b divided by 2 squared. I like to write what I get in here. So I get 4 squared. So 16. 16 is the magic number I'm going to add and subtract. So in here, I add 16. So now I have a perfect square trinomial. I need to remember to subtract 16 as well, so that I'm overall adding 0, right?
Yeah.
Right, overall you want to add 0. So now I can finish. I can write y equals 2 times, do the perfect square trinomial. So it's x, and then just look at, that's why I like to do this. Look at that number, that's the magic number you're going to write in here. And then 12 subtract 16 gives me negative 4. Oh, I made a mistake.
Make a mistake.
I did. Anyone see it? Actually, well, so I'm okay. I'm okay up to here, sort of.
Is it minus 8?
Yes. Yeah.
You
So
got
why?
2
Well, how did I make my mistake?
last time. 2 to 4.
I lost the bracket. So remember. So here's what some people are starting to notice. This 2 was multiplying everything, right?
Yeah.
Because I got to be able to get back to here. When I went to this step, I'm still fine. I got my big square bracket, so the 2 is multiplying this. It's multiplying everything. But when I got to this step, I didn't adjust this term, right?
Yeah.
Like, it was 2 times this stuff. And then I wrote the 2 here, so once I get to this bracket, it stops applying. I didn't adjust that
Okay,
term.
you forgot the
Yeah,
bracket.
so I need to remember that once you do this and I get 4, I need to remember, hey, it's 2 times 4, so this should have been 8. And that's a super common mistake. So I did it on purpose.
Sure.
Yeah, no, I totally forgot. Sort of, I mean, I remembered as soon as I got to the last step, right?
Oh, okay, so you just forgot a bracket.
I forgot that the 2 applied to everything. So once you do this,
Yeah.
and I get 4, well, negative 4, I need to remember, hey, it's 2 times negative 4, so I get negative 8. Because this 2 only applies to this after you FOIL it out, right?
So can you go 2 big bracket x plus 4 squared minus?
No, because this is your A term, right?
Okay.
So you want it to look like standard form. So if you start, so you need to deal with what is this number once you adjust for whatever's out here, okay? So whatever's out here, you're gonna multiply this by whatever you get over here for your constant term.
Alright, I see.
Yeah. And you only need to worry about that if A is not 1, right? If A is 1, then it's all fine. But okay. I mean, we can do. I think there's a try it yourself. Yeah, we can do. We'll quickly do the try it yourself. I think it says what's the. Does it ask us what the vertex is? They want to know what the vertex is. So just really quickly to wrap it up, the vertex is negative 4, negative 8, right? Okay, let's try the try it yourself. So it's just the same question type, just with different numbers. Now this one's nice because we will get some ugly numbers. So this isn't 1. So your first step is pull out the 3, right? So pull out the 3. So I'm going to divide everything by 3. So I'll throw a 3 out in front. The first term you get x squared. The next term you get negative 4x. And then you get plus 7 divided by 3. I can't divide that evenly, so I just leave it like that.
Can you put it into a decimal form? I mean, you could do it.
No, I'm sorry. You guys are taking grade 11 pre-calc, so we gotta leave it as a fraction.
Yeah.
Now leave it as a fraction because it maintains your accuracy and you don't have to write a bunch of decimals or worry about rounding. Okay? Yeah, don't fear fractions. Now I can complete the square, right? So I'm gonna do it like this. So I like to go x squared minus 4x. I leave myself some room. I write the 7 over 3. I'll leave myself some more room. Close the big square bracket. Okay, grab your b term. Divide it by 2. Put brackets around it. Square it. And then write what you get here. So negative 4 divided by 2 is negative 2 squared. So I'm going to add 4. Okay, so I add 4 in here. And then I need to subtract 4 over here. Yeah? So that overall I get 0. Okay? So, let's do this. Don't forget, I don't know what we can do here so we don't forget, like, if I circle this, like remember that the 3 needs to multiply whatever answer you get there, okay? So, just off to the side, 7 over 3, whoops, 7 over 3, subtract. If I change this to something over 3, it'd be 12 over 3. Do you guys agree?
Yep.
Right, just multiply it by 3 over 3, you'll get 12 over 3. So I do the work and I get negative 5 over 3. So I need to remember to go 3 times that. So 3 times negative 5 over 3 is equal to just negative 5, right? Okay, so when I'm rewriting this, that's my a term. I can do the perfect square trinomial there, so I get x minus 2 squared, and then I go subtract 5. You guys want to know like the most common error? There's two.
Probably
Not factoring out, not making this one,
Yeah.
which tells me that you've done zero homework, and then also forgetting to multiply those two things to get that number. Yeah.
So if it's not gonna make like a nice number, just keep it as a fraction.
Yeah.
You possibly use like the quadratic function. Oh no, that's just to find the roots though. Never mind.
Yeah, so Kevin just asked like, hey, like could I use the quadratic formula? You could, it would give you the roots.
Yeah.
Right? But so if I was asking for the vertex, that might not help you very much.
Yeah.
Although, if you have the roots, can you find anything about the vertex?
You can find the x.
You can find the x value of the vertex, right? So as an aside, remember the x value of the vertex is always right between the two roots. Now that's great. What if you get a question that doesn't have roots? Like we just graphed one that doesn't have roots. So would you be able to find the x value of the vertex using this equation?
No.
No. So this helps sometimes, yeah.
You gotta use negative b over 2, right?
Yeah, we'll actually talk about that in a second. So vertex is 2 comma negative 5 for this one. And then I suggest that, you know, so we've done 2 questions. You need to check out the homework assignment and do more. Guys, me personally, like I don't know, like when I was in high school, I wasn't ready for something until I'd done most of the questions about twice. And I'd usually go over my notes. So some questions I do 4 or 5 times. Just so you guys know. Okay? Should I give you one of my favorite analogies?
Sure.
Yeah. You not doing any work on your own, like not spending about like an hour or so every night on your own, probably, like just on average. It would be the equivalent of you coming to the gym, watching me work out, and expecting to get really buff. Right? Like right now you're watching me do some math, which is good, it helps, but you also need to go do it yourself, right?
Can you give us a question?
Watching someone helps you at all. What do you mean?
Yeah, no, well, it's very limited, yeah. It'd be like me watching football and being like, I'm getting so good at football. It's like, well, kind of. Like, I'm getting ideas watching them play, but if I never practice them, I'll never get good, right?
Can we get an equation?
Can you get an equation?
Yeah.
Wait,
To
what?
practice. You know.
What?
You know,
Right now.
it's like,
An equation?
yeah. So like we can practice. So or like
Anybody
question.
understand what kind
Yeah. Just give us a question.
Well, that's what your exercise book is questions.
But like.
Just do whatever you want.
You guys are funny.
I'm not
Okay.
a question.
All right. Yeah, sometimes completing the square can be messy. Like this one, what do you like? I don't need to factor anything out, but I'm going to take the b term, divide by 2, square it, so you get like 25 over 4, and it can be messy. So there is, if you're just looking for the vertex, like I'm not saying write it in standard form, I'm just like graph this. There's a formula you can use that gives you the vertex, which we don't have time to talk about like where it comes from, but this will give you the x value of the vertex. As long as you have it in general format, so the negative b over 2a would give you the x value of the vertex. So in this case,
Does the x value always have to be 1 still, or can it be any?
no, the x value of the vertex could be anything, yeah.
Okay.
So if I plug in b, which is negative 5, I go negative 5 over 2 times a, which is 1. So the x value of the vertex in this case is 5 over 2. And then how would I get the y value?
Plug it in.
Yeah, substitute it back into the equation. So once you have that, you can say, well, the y value is just me going back here and substituting it into, what is it? X squared minus 5x. Is it plus 1? So just substitute it in. No one ever said it would be nice. And then you should be able to work that out. Let's quickly work it out. I smell fear. You guys don't like fractions.
Yeah, why do we have to use fractions?
What is going on?
Wait, shouldn't?
My question to you guys is, what series of math teachers did you have up to this point where you guys aren't comfortable with fractions?
It's just easier to visualize it.
I mean, I don't actually want you to answer. I'm just like, I used to teach grade 9 and 10, and the focus was fractions. So like, what happened in the?
I don't know.
Or is it just you guys? Is it just you guys like doing?
Probably just us.
doing like what you do, where it's like, I have to do work to get good at stuff?
Yeah,
What?
I know, it's so surprising.
I've always used decimals. Ever since grade 4, I've been using decimals.
Hey, so what do we get? We square it, we get this. 5 times 5 is negative 25, so you get this. And now it looks like I'm going to get a common denominator of 4 everywhere. So when I do this, put it as something over 4, it's going to be, just multiply it by 4 over 4. I'll change this one. What's that one as something over 4? It's 50, right? Just multiply it by 2 over 2. So you'll get 50 over 4. Yeah, I don't know. You guys stress me out. So now I got the same common denominator, so 25 minus 50 is negative 25. Add the 4, I get negative 21 over 4. And now I know my vertex. Now, like, would we ever give you something like that to graph? Like, not really. Because like it's hard to graph. This is 2.5, and this is approximately like, 5.25. It is 5.25. Like, we don't generally give you things that are tricky to graph. But I could easily just be like, hey, what's the vertex for this? Right? And that would be your answer, right? So I don't have to get you to graph it. Yeah, we usually get you to graph nice looking things, but I could easily ask you questions like this where you have ugly numbers. Yeah. Okay? Alright. Good talk. Let's see. Factoring and completing the square can sometimes both be used in a question. Yeah. Yeah, okay, so it's just another question where we're going to complete the square to get the vertex, and then we can also just try regular factoring. So it doesn't matter, how you do it. You can do it whichever method is convenient for you, unless I specifically say like complete the square. What are we doing for time? Okay.
We got 10 minutes, 7 minutes.
So they just want the x-intercepts. Okay. And then we'll get to general form. Wait, it's 10 past? Is it 10 past? Okay. Yeah, okay, so just in the interest of making sure we get to the last topic, which is sort of fast, we'll skip this. Right, it's just looking for the x-intercepts. Me personally, you guys, completing the square gets you the vertex, and it kind of makes it easier to solve for the x-intercepts, but for me, I would probably just factor this one if I was looking for the x-intercepts. Right, but it's just saying, hey, you can complete the square and get the x-intercepts, or you can factor and get the x-intercepts. This is just, what kind of factoring question is this? Well, that's what I'm asking you guys. You just asked me my question. What would I use to factor it? What method?
I'll probably use just regular.
It's not a equals 1, right? So it's a decomposition?
A, oh my god.
Right? So you're looking for two numbers that multiply to a times c and have to add up to b.
Yeah.
So what's the b term? Negative 1 and a times c is negative 6. What are my two numbers?
Negative 3 and 2.
Excellent. Negative 3 and 2, right? And then you would decompose. Yeah. I can't reteach you the last unit, but that was the last unit. If you can come see me after. Okay, let's convert. So converting it is easy. If you're going to convert something that's standard form into general, so you just FOIL it out. FOIL and group like terms. So that's how you do it. So here it is in standard form. You want to get it in general form. So I'm going to FOIL. So I'm going to expand this. Remember, it's a perfect square trinomial, so you can sort of use the formula to help you, or you can just FOIL it. And then don't forget to subtract 5. Distribute the 2 into the brackets. So I'm going to get 2x squared minus 12x plus 18. Subtract 5. Can still group the constant terms. So I get 2x squared minus 12x, and then that's plus 13. Yay!
Can it be minus minus?
Nope.
It's
Yeah, because I'll get x squared, and then I'll get negative 3x twice, and then negative 3 times negative 3 is positive then. Some people are unhappy with the foiling. Right, so x times x squared, x times negative 3, negative 3x, negative 3 times x, negative 3x, negative 3 times negative 3, 9, yeah? Welcome to grade 11 pre-cal. It's good? And by the way, like if you're gonna write it out, please like write it out. It takes you an extra 3 seconds and then you can be confident that your answer is correct. Yeah.
Oh.
Let's do another one. Any questions for A?
Can you come check the work?
Not turning that. No, sorry.
Cool.
Come on back. You should get this. Okay, general form again. You guys want to give it a shot and then I can throw up an answer? Or? Are you guys always this happy or?
Yeah.
Just a bunch of daddies in here. Let's see. Okay, so I expanded it out. I'll show my work if anybody wants to see the expansion. You get x times x squared, and then you're gonna get 1x, and then you're gonna get another 1x, and then you're gonna get plus 1.
Yeah.
So yeah, that gives me the 2x in the middle. I'm gonna distribute the 3 into the bracket, so I get negative 3x squared minus 6x minus 3, subtract 2. And then like a sucker, I'm gonna rewrite the whole thing. Just because of one term, I get the negative 5. Honestly, if it was a test, I would actually probably erase this and just, but it's fine. This way you can see all the work. All right. So what would we do in part C? It was the entire lesson. How did we do it?
Take out 2.
Yeah. So Kevin, you're saying we need to complete the square. Complete the square. So I'll try to finish it. I think, yeah, we should have time. So it's just another question where we're just completing the square. Gotta make this positive 1. So I'm gonna go y equals, I'm gonna pull out the 2 and divide every term by 2. So the first term I get x squared. Negative 8 divided by 2 is negative 4. Okay, remember I like to leave some room. So I'm gonna complete the square in the brackets. 1 divided by 2 is 1/2, like that, okay? So I just did that to leave myself some room. Then I'm gonna grab the b term, gonna divide it by 2, gonna square it. So it's negative 2 squared, which is 4. So 4 is the magic number. I'm gonna add 4 and subtract 4. Gonna start completing the square. I'm gonna go 2. This is a perfect square trinomial. It's x minus 2 squared. So just a reminder, you can grab the number you have here. You can pop it in there. You're always guaranteed that it'll work. Okay, I gotta remember to multiply this by 2. So off to the side, I'm gonna go 1/2 minus 8 over 2, which is 4. So that gives me negative 7 over 2. Okay, when I multiply negative 7 over 2 by 2, those cancel, and I'm just left with subtract 7. And there's my standard form. Okay?
Oh yeah, you're right.
So that's what you guys got to practice today. I think at the end of the notes it says you're doing exercise 26 today. Really quickly, if we have time, do you guys want to expand this out and see how you get back to general form, or you guys believe me?
No, let's expand it.
Yeah. Okay. That's good. You should try. If you expand this out, you should get back to where you started. It's a method of checking your work.